Okay, Assalamualaikum warahmatullahi wabarakatuh. So, we are going to continue our discussion on the topic of enthalpy change of reaction, and we are going to talk about calculating enthalpy change of reaction using the enthalpy change of formation data. So, the formula used here is enthalpy change of reaction equals the sum of the enthalpy change of formation of the products minus the enthalpy change of formation of the reactants. So to illustrate this, we use the reaction between ammonia and oxygen. So here 4 moles of ammonia reacts with 5 moles of oxygen, producing 4 moles of nitrogen oxide gas and 6 moles of H2O steam. So make sure you get the correct physical state symbols here for the reactants and the products. So calculate delta H reaction, enthalpy change of reaction from delta HF values. So you can look up for these values in your textbook or your tutorial book. So here the values for the delta HF of nitrogen oxide is 90.3 kilojoules per mole. So we have here 4 moles, yeah. Use the general equation, the general balance equation. For 4 moles, so you have to multiply 90.3 kilojoules per mole multiplied by 4. And then H2O gas, delta HF is negative 241.8 kilojoules per mole, to multiply by 6. So the values of ammonia, delta HF ammonia is negative 45.9 kilojoules per mole times 4, and that of oxygen is 0. So why is oxygen 0? Because oxygen is not a compound. Oxygen is an element. So you have to recall that the definition for the enthalpy change of formation is the enthalpy change when 1 mole of a compound is formed from its elements at standard state condition, which is 25 degrees Celsius and 1 atmosphere. And you can also calculate the enthalpy change of reaction based on enthalpy combustion data. Yeah, and so here delta H combustion of reactants minus delta H combustion of products. So please get the formula right. So these are the two formulas that you can use to calculate enthalpy change of reaction.